All right, so I'm supposed to do number 37 in 14.6, which is chain rule-y things.
Yes.
And they tell me that I'm supposed to suppose that x is bigger than 0, y is bigger than 0. Right, so I'm looking first quadrant D. And then that z can be expressed as a function of either Cartesian coordinates or polar coordinates. So they tell me, first things first, z can either be f of x and y, or possibly some other function g of r and theta. I'm super bad about naming conventions. So you will notice that sometimes when I convert from cylindrical or from Cartesian to polar like this, I'll call both of these f. They have different formulas though, right?
Programming does it.
So this is some formula in the regular rectangular things and some other formula in the r and theta things. Easy examples would be something like f of x and y is x squared plus y squared. What's the g of r and theta that goes with that?
Constant.
R squared. You guys cool with that? Right? It's constant with respect to theta, but it's just whatever the square of the radius is. You guys cool with that? You know the formulas to go from this to that, right? Let me rephrase that. You better know the formulas to go from this to that. X is what? In terms of r and theta. Don't worry, we're going to need these. So x is r cosine theta, and y is r sine theta. Okay, so they tell me, recall that, and that r is the square root of x squared plus y squared, and theta is arctangent of y over x. Oops, arctangent, how about that? Of y over x.
What is just arc y over x? What is that?
Nothing. That's why I need the tangent part. Okay, so they want me to find the partial of z with respect to r and the partial of z with respect to theta in terms of the partial of z with respect to x and the partial of z with respect to y. Okay. So partial z with respect to, say, r, right, should be the partial of f with respect to r, right, on the one kind of hand. And on the other hand, that should be the partial of g with respect to r. Okay, see that? This is like a straight partial that I would just execute, right? Because g depends on r's and thetas, so I would just do that. That's cool. But this one is not just a straight partial because f doesn't depend on r except through x and y, right? So this is my chain rule step. So when I chain rule f with respect to r, what do I get? What do I need?
dx, dx, dr. Well, that's the first part.
Okay, I need the partial with the partial of f with respect to x, and the
Derivative of x with respect to r.
ooh, yeah, okay. So
Oh, wait,
x
it's
is
a
with
partial
respect
because
to
of
r.
the theta. Because of the theta, it's a partial. Okay.
Yeah, and this is definitely a partial. So we're doing chain rule part 2, right? Kind of. I don't really care if you think about which part of the chain rule you're using, as long as you get the character of the del's or the d's right. What's up?
Can you re-explain when you use a hard derivative versus a partial? Just
Yeah.
a little bit.
So if this function x, right, depended only on r, then these would be hard derivatives. But because x depends on r and also some other variable theta, these are partials. So here I have the x slope of f and the r slope of x. So that accounts for the x bits. Then what else does f depend on?
Y.
Y. So I need the partial of f with respect to y times
Partial of Y with respect to R.
partial of y with respect to r. You guys all see that? Some of these things I can execute right now. So which things do I have formulas for that I can hammer on right now?
X and Y.
Let's see, so if I had a formula for x, right,
Which is
I could do the partial of f with respect to x. But I don't have a formula for f.
Oh,
F is just some function.
Okay.
So that piece is not accessible to me right now, at least. If I had an example, I could do that, but I don't have an example. But the partial of x with respect to r, I think I know how to do that part.
Yep.
So these guys are accessible, and the other two are just kind of, I don't know, you'd have to do that when you had a function. So we're going to get the partial of f with respect to x times,
Cosine theta.
good, times cosine theta, plus the partial of f with respect to y
Sine
times sine theta.
And you just leave those as theta, you wouldn't put in the arc and y over x.
Ah, yeah, and I would leave those because I am trying to calculate a partial with respect to r. You guys see that?
Yep.
And really, if I wasn't lying to you a little bit, I would have another thing here, which is these guys, right, are categorically what?
The cosines? Is that what you're talking about? I didn't know what you
No,
were
this partial f with respect to x. What category of thingamahoo is that? It's a function of what? Yeah, it's a function of x's and y's, right?
Yep.
You guys see that? But I'm trying to calculate an r derivative, right? So that should include some kind of evaluated when x is r cos theta and y is r sine theta, right? So you have to be a little careful with where you're evaluating these things. That's cool. Okay, so that'll give me partial of z with respect to r is given by this formula. So can we calculate the others? You guys want to see them, or should I leave that as an exercise? Is that enough to get you started?
Yeah.
Okay.
Were we also supposed to do partial of theta?
Yeah, so we're actually supposed to do both of these. So if we do the partial, let's do it. What the heck? So partial of z with respect to theta then is the partial of f with respect to theta, right? And then a chain rule tells me that that's what?
df dx dx d theta?
Should be the partial of f with respect to x, and then the partial of x with respect to theta. Right? And then partial f with respect to y, and the partial of y with respect to theta. Is all good? Why don't you have a partial of f with respect to r, and then a partial of r with respect to theta?
Because r and theta are at the same level? Is the best way to describe it?
Yeah, that's cool. You can think about that. But they're in the r and theta are in the same place. It doesn't make any sense to differentiate one with respect to the other. You guys see that?
Oh, another way, there's no function of r using theta as a solution, I guess?
Yeah, there's r doesn't depend on theta is another good thought. And yet another thought is that f doesn't depend on r, so what do you do with it, right? F only depends on x's and y's. So these are that first level dependence, right? And then we would worry about second level dependence as we differentiate.
Could you substitute?
Yeah, and of course you could actually substitute, right, to calculate these things.
Because if you say x equals r cosine theta and y equals r sine theta, you just put r cosine theta and r sine theta.
Yeah, so that's how you get from the function f to the function g. And what they're trying to get you to do here is to cobble together some formulas for converting from regular partials to polar partials and back. You guys see that? Like that's what this thing is. This gets me into those R partials. All right. Let's see, which parts of this can I calculate and which parts are unknown to me?
X's, thetas, and del's.
Yeah, the theta derivatives, right, I can calculate, and everything else is unknown. So I got the partial of f with respect to x, and then what's the theta derivative of x?
Oh, that would be negative product through product rule? Yeah.
Wait, through the product rule.
Well, I just, the left side cancels out, then you plus the other side. That's how I did it in my mind. Maybe there's a faster way, but
Yeah, I'd probably just say r is constant with respect to theta, right?
yeah.
So that floats through, and then the derivative with respect to theta of cosine is minus sine.
Yep.
Yeah.
Makes sense.
You can use the product rule
As
too,
long
and
as I
then
get there
notice
in
one
the
of the
end, I do
parts
it
is
fast.
0. You can always use the product rule, it's just sometimes longer.
Yep.
Right, like when you're differentiating r with respect to r, you could write that as the product rule of 1 and r. And you,
Yeah, I was gonna ask, you just leave your problem with untreated partials then, like for F?
yeah,
Okay.
because I don't know what those are. They'll change, right, depending on what the function f looks like. Yeah. Let's see, so I got this bit, and then I got the partial of f with respect to y. And then what's the derivative of y with respect to theta?
R theta.
Let's do something up here. Okay, so that's part A. Part B is solve the equations you have just written down for the partial of z with respect to x and the partial of z with respect to y in terms of the partial with respect to r and the partial with respect to theta. What? Huh?
Oh, so now we do it using G, we do dz, dx using del, g, del.
Okay, so let
Is that
me
what we're supposed to do?
let me summarize what I just found here. I'm gonna dump this stuff. I'm just kind of dumping my work, right?
Yep.
Let's see, and they're saying something about partial of z with respect to x. I don't have any of those. Where are they?
X's?
They were in
Where's the-
theta.
No.
They're in the
R
functions?
is y is in theta, right? R
Wouldn't-
and y.
Yeah. So you're right that that dependence exists, but someplace up here on the board is written partial z with respect to x, but it's not written that way.
Because
Not
of
partial
that.
f.
Yeah. So these guys are the partial z with respect to whatever that they're talking about. Okay, so they told me I should take the two equations that I just wrote, which are these guys. And this one's the partial of z with respect to r. And I'm supposed to solve these for the partial z with respect to x and the partial z with respect to y. You guys see how to do that?
Partial, use the partial of g.
Yeah, like just treat everything like it's numbers. Solve. Cool? You guys manage that one? Okay, so after you do algebra 2 to this, you'll get some formulas. And then part C says, show that the expressions you get in part B are the same you would get by using the chain rule to find the partial of z with respect to x and the partial of z with respect to y in terms of partial z with respect to r and partial z with respect to theta. In other words, if you do these calculations and then some algebra, you get the same stuff you would get if you just did the chain rule the other way. Does that make sense?
So if we solve these for partial z, partial x, and partial z, partial y, would we need to add them both together or something, or just?
Yeah, you'll want to do some elimination of variables. It'll be super annoying. You guys know what I mean by that?
You're talking about solving for dz dx and then popping up the other equation?
Yeah, so if you just solve for partial of z with respect to x by algebra, and then substitute it in there, That would work.
We eliminate a variable.
You would get rid of the partial z with respect to x variable, right? Or you could also, yeah, definitely don't subtract this over there, subtract that over there, and then try to equate them. That won't be nice. What you could also do is treat these like two linear equations and do elimination. You guys know what I mean by that? That's this thing where you have like 2x plus 3y is 7 and minus x plus y is 8, right? You could solve this equation by multiplying this whole second equation through by 2 and then adding them together. You could do the same thing here. It'd be a giant pain in the ass, but it's probably better than solving and substituting. Cool? You want to multiply this one through by like r and a sine, and that one you want to multiply through by a cosine, and then when you add them together, this middle variable will drop out or something. Cool, cool? All right, I trust that you all can execute the algebra from here.